Hi everyone, in this video, the law of the junction is introduced. Although the law of junction is not a strict law, it is quite useful to understand the non-equilibrium behavior of a p-n junction. Here, the non-equilibrium is caused by a non-zero anode voltage when the cathode is grounded. At equilibrium, the electron density n and the hole density p can be functions of the electrostatic potential. Now we wanted to compare the electron densities at 2 points across the junction. One is x equal to minus wdn and the other is wdp. We can find that two densities, the majority electron density in the n-type region and the minority electron density in the p-type, are related with an exponential function of the potential difference. So, what is the law of the junction? It is for the minority carrier density at an edge of the depletion region. The previous relation, which is strictly valid only at equilibrium, holds approximately even at non-equilibrium cases. Then, the potential difference can be written by using the built-in potential and the anode voltage. With this expression, the minority electron density is given by its equilibrium value multiplied by the exponential of the anode voltage. What does it mean? Consider our typical example of ND equal to 10 to the 20 per cubic centimeter and A equal to 10 to the 17 per cubic centimeter. Then the minority electron density in the p-type region is 10 to the 3 per cubic centimeter, of course. When a forward bias voltage is applied, the electron density at WdP increases. For example, with 0.3 volt, it becomes 10 to the 8 per cubic centimeter. On the other hand, when a reverse bias voltage is applied, the minority electron density decreases. Let me show you a numerical example. Two bias voltages, 0.3 volt and 0 volt, are applied to the anode terminal. The figure shows the electron density in the p-type region. The junction is located at a position of 1 micron. At equilibrium, we can see that the depletion width is about 110 nanometer. The minority electron density at equilibrium is about 10 to the 3 per cubic centimeter. When the bias voltage is 0.3 volt, it becomes about 10 to the 8 per cubic centimeter, following the law of the junction. In the next video, we will study the IV relation of a p-n junction. Thank you.